Hello to everyone, my name is Dastan. I'm a student of Süleyman Demirel University, and now we're gonna talk about our topic. So our topic is regular expressions. So what is a regular expressions? Regular expressions is a string pattern used to search and manipulate text. Regular expressions are used in many situations of computer programming. Majorly in search, pattern matching, parsing, and filtering of results, and so on. Regex has a special syntax. There is a lot of operations. For example, zero. This expression should contain numbers. And next operation is or. For example, if we have a string like expression like this. This expression accepts only one of these. So, for example, A or B, A, B. Then it means that this expression can accept only A or B. And the next operation is closure. It symbols star. So it means 0 or more times. For example, if we have A, B, closure, and A, it means this expression should contain only A, B, and A. It means 0 or more times B. So next operation. Next operation is at least one operation. For example, if we have A, B, C plus D, E, it means we can this expression can accept only A, B, C, D, E, and A, B, C, D, A. Plus means 0 or 1 or more times.
My name is Yasemin. I am a student of Süleyman Demirel University. So, our topic was the regular expression, and my friend Dastan has explained about regular expression and its operators. Okay, so I will explain you the DFA and NFA and between. So, the finite automation can be classified in two types. Okay, it is a deterministic finite automaton and a non-deterministic finite automaton. Okay, so deterministic finite automaton, DFA, for each input symbol, one can determine the state to which the machine will move. Hence, it is called deterministic automaton. As it has a finite number of states, the machine is called deterministic finite machine or deterministic for understanding the DFA, let's consider the following state diagram. Okay, so I will image the state diagram, okay, and after that I will explain you this diagram. Okay. Q2, and this one. So what does it mean, this state diagram? Consider the string, for example, 1, 1, 0, 1. Okay. After the entire string 1, 1, 0, 1 that has been processed, the machine is in state Q2. It is our accepted state. which is an accepted state. Okay, we say that the string 1101 is accepted by the machine. Okay, for example, the first one it moves by this state. Okay, and after that one again it moves like this, and 0 it moves to Q3 state. After that 1 it moves to the accepted state. Okay, so consider the another input string like 0 1. Okay, 0 1 and 0 1 0. Okay. This string will reject it, okay? Because after having to read the string from left to right, starting in the start state Q1, the machine is in state Q3, since Q3 is not an accept state, okay? We say that the machine rejects the string 0, the string, okay? So let's, I will show on the state diagram. The first is the 0. It moves like this to Q1. It stays on the Q1. After that, 1 moves to state Q2. After that, 0. 0 moves to the state Q3. Okay. After that, again 1, it moves to Q2, and again 0, 1, and 0. Have you seen the Q3 is not accepted state? It is this string will reject it because accept state here Q2 is accepted. Okay.
My name is Uraz. Now I'm going to explain about NFA. In NFA, for the particular input symbol, the machine can move to any combination of the states in the machine. In the other words, the exit states to which the machine moves cannot be determined, and hence it is called non-determinist automata, as it has finite numbers of states. The machine is cannot non-determinist finite machine or non-determinist finite.
About the NFA, we will explain the NFA on the example. My friends, for us, we show the state diagram, and after that, I will explain you what this diagram means. Okay, here you can see the Q1. It means that it is in the start state, and that all this Q1, Q2, Q3, and so on. It is all the states, and the Q4 it is the accepted state. Okay. Okay, here you can see the empty string. What does it mean? It means that you can move without any string. Okay, you can move state without any string input. So, what the strings? What is this? So now let's talk about the difference between DFA and NFA. The first difference is DFA. DFA has only one transitions for every input symbol at every state. Okay, and the NFA may have several transitions for every input symbol at every state. What does it mean? For example, this state diagram belongs to NFA. Okay, here you can see that you have several transitions for two states. Okay, it means that one can move, change its state to Q2, and also again one can change state to Q1. In DFA, we cannot do like this. We can also move the change state from Q1 to Q2. Okay. transitions. Okay. The second difference is the DFA. In the DFA, empty string or epsilon are not possible. Okay, what is this? It is this one, epsilon. In NFA, it is possible. It is the main
Regular expression matching to NFA. So let's convert these regular expressions to NFA. So let's draw it. So match the transitions. Okay. So let's talk about transitions. So these transitions, this and this one, it means change state and scan to next texture. And this transitions means change state but don't scan text.
So, okay, let's talk about the closure expression. Here we can see between A and this operator, we can see the backward and forward empty transitions. Okay. So what it means? What does it mean? For example, we have things like this. Okay. So when from the A, the state will change from the A to this operator. The first A in the input will scan. After that, from this operator will change the state to the B or A, it scan the next character, and the A will be accepted and the B will be rejected. And after that, the A again will change the state and scan the next operator.
We have already talked about the regular expressions and what is the NFA and the DFA and the difference between DFA and the NFA. So let's talk about the NFA representation and the structure of NFA. So here you can see the state names. What is this? The state names is the integer from 0 to m. M is a number of symbols in array. You can see here the 0, 1, the oldest numerical order is our state names. Okay, so match transitions. What is a match transitions? Match transitions, it is all the transitions that keeps in the regular the array regular expressions array. You can see here. Also, we have empty transitions. All empty transitions store in a dgraph tree. Okay, so in here in this state diagram, you can see the empty transitions by the red link. So NFA simulation, we have questions. How to efficiently simulate an NFA? The answer is a maintained set of all possible states that NFA could be in after reading in the first I text characters. So you can see here the all states reachable after reading I symbols. It is after the reading I symbols. Okay, it is the second is the possible transitions of reading I plus one as the symbol C. The third is the possible null transitions before reading next symbol, and the last is all states reachable after reading I plus one symbols. The next question is how to perform legibility. I've already explained with the closure expressions and the E transitions and the match transitions and so on. So in here we can see the NFA simulation. So I think this simulation will be useful for. Let's talk about NFA implementation on the Java. Here you can see the public class NFA and its variable. It's variable like area. It is an array that's type is char and dgraph g and the integer m. It is a number of states m. So also we can see the constructor NFA. Its parameter is accept the input of string. It accepts a string. Okay, so m is equal to input length. Array is equal to the we have to translate our convert our input to the char array. Okay, G is the root epsilon transitions graph. Here's the NFA simulation on the Java implementation. Here we can see the public Boolean method recognizes its parameteristic C thing. Also, here we can see the bike array. Its type is integer, and we call the exemplar and our PC will be the variable of this exemplar. Okay, and directed DFS. Directed DFS we call the class the directed DFS. We call make the exemplar. After that, we open the loop for, and our loop will continue until the end of our vertices. Okay. Why we use the recognize method? It's used for states reachable from start by E transitions. Okay. Here we find the states reachable after scanning past txt chart A. Here we follow E transitions. And here we accept if can end in state M. So guys, now let's talk about the NFA construction. For building NFA corresponding to a regular expression, our states have to input a state for each symbol in the regular expressions, and plus an additional accept state. You can see here of the states of this regular expressions like this, and the plus additional accept state. Here we can see the concatenation at match transitions, H from state corresponding to the character in the alphabet to next state. Also, we have the alphabet A, B, C, D, and the meta characters like the left and the right parenthesis and the point, closure operator, and the OR operator. Okay, about this operator, my friend Dastan have already explained. in here, parentheses add e transitions each from parentheses to the next state. Okay, this red pointer, it is e transitions. It is empty transitions. What is empty transitions? You know that empty transitions is we change state, but we don't scan the next chapter. Okay. Here we can also can see the black pointer. It means that we change state, also change the also scan the next input, next chart. Here explanation about single chart closure, the closure expression. We have already explained about this one. It looks like this. So NFA construction here about how to NFA, how we should to construct the NFA. Our goal is to write a program to build the e-transitions digraph. Okay, so our challenge is remember left parentheses to implement closure and OR. Remember OR to implement OR. Okay, solution to maintain a stack. It is a left symbol. Push onto the left, push the left on the stack, and the OR symbol, if we can scan the OR symbol, push OR on the stack, and also if we scan the right symbol, pop corresponding and any intervening OR. Also add e-transitions H for closure or OR. Okay, it will look like this. So guys, let's show you a video about the construction of NFA. I think this video.
So guys, let's talk about difference between DFA and NFAs. If you start a DFA in its initial state and input some word y, the state q in which the DFA ends up is completely determined by y. Inputting y to the DFA will always cause it to end up in state q. This is what is meant by calling it deterministic. And if you start an NFA in its initial state and input some word y, there may be several possible states in which it can end up, since some of the inputs along the way may have allowed the choice of state changes. Consequently, you can predict from y alone in exactly which states the automaton will finish. This is what is meant by calling is non-deterministic. And it's actually a little worse than I've indicated, since an NFA is also allowed to have more than one initial state. Finally, these differences affect how we determine what words are accepted or recognized by an automaton. If it's a DFA, we know that each word completely determines the final state of the automaton, and we say that the word is accepted if that state is an acceptor state. And if it's an NFA, there might be several possible final states that could result from reading a given word. As long as at least one of them is an acceptor state, we say that the automaton accepts the word. So what I've described informally is a view of an NFA that makes it look most like a DFA, and that I think best explains why it's called non-deterministic. There is, however, another way of looking at NFAs. It's also possible to think of an NFA as being in multiple states at once, as if it were making all possible choices at each input. If you think of it in those terms, you can say that it accepts a word provided that at least one of the states in which it ends up after reading that word is an acceptor state. This point of view is perhaps most useful for understanding the algorithm used to turn an NFA into an
So
equivalent
guys,
DFA.
in this video tutorial, we have talking about regular expressions, about the NFA and the DFA, and the difference between the NFA and the DFA, and the implementation of NFA on the Java, and the NFA structure, how to rightly construct the NFA, and so on. And we have tried to explain and describe the all main content about the regular expression and the NFA and the DFA. I think this video tutorial will useful for you in future. Were with you Rabbi Dastan, Yasamin, and Ramalbek Warazgilde. Thank you.